Today's lesson is actually going to take place in two parts. Factoring is a very important concept. It's something you're going to need in this unit and the next unit. And you're actually going to start off Algebra 2, talking about factoring. So this is not an idea that's going to go away. Our essential question is, how do I factor polynomials? All right, to begin with, we sometimes have to factor out a common monomial, or a greatest common factor from our polynomial. If you recall, a greatest common factor is the largest number that you can divide into both of the numbers you're looking at. As I look at 15 and 3, I can divide both of those by 3. And if I divide each of these terms by 3, 15 divided by 3 is 5, keep the xy, plus 3 divided by 3 is 1. Looking at the next one, I have a 4, a 24, and an 8. The greatest common factor here is 4 in terms of the numbers, but I also need to look at the variables. X to the 5th, x cubed, and x, I can all divide by x. So when I divide each of these terms by 4x, let's see, 4 divided by 4 is 1. X to the 5th divided by x is x to the 4th. Negative 24 divided by 4 is negative 6. X cubed divided by x is x squared. 8 divided by 4 is 2. And x divided by x is 1. Right. When I look at my next example, 13 and negative 3. There's nothing there in terms of the numbers. 13 is 1 times 13, and 3 is 1 times 3. The only thing they have in common is 1. But the variables have some things in common. A squared and A, I can divide by A. B and B can be divided by B. C and C squared can be divided by C. So I have to divide each of these terms by A times B times C. I'm going to keep the 13. A squared divided by A is A. B and C cancel out. I'll end up keeping the negative 3. A will cancel out. B will cancel out. C squared divided by C will be C. Okay, for the next one, 25x squared minus 35x plus 10. They all end in 5 or 0. So I can definitely pull out a 5. I could pull out an x from here and from the x squared and the x, but not from the 10. So it's just going to be a number this time. We'll divide each term by 5. 25 divided by 5 is 5. Keep the x squared. Negative 35 divided by 5 is negative 7. Keep the x. 10 divided by 5 is 2. Next up, negative 3, negative 12, and 14. Well, let's see. 3 is 1 times 3. 12 is 1 times 12, 2 times 6, 3 times 4. Maybe the 3's? 14 is 1 times 14, 2 times 7. I don't have a 3 with the 14. So there's no number I can pull out. I've got an x squared, an x, but no x with the last one. So this one, we call it prime because we can't factor anything. All right, let's look at the last one, 30 and 24. Let's say that you don't know what to divide into both 30 and 24. So let's look at our graphing calculators. We come here to math, and we arrow over to number. We can come down to GCD, enter, 30, comma, 24, close the parentheses. lost my smartboard for a second. There we go. Our greatest common factor is 6. Now your calculator will only do 2 numbers at a time. So if you have a trinomial, the calculator is not going to help you with it. But it was math, arrow to number, and then arrow down to GCD. So we're going to be able to pull out a 6 from both of these, and also an x. So we're going to divide both sides by 6x. Let's see, 30 divided by 6 is 5, and x squared divided by x is x. Negative 24 divided by 6 is negative 4, and the x's cancel. You always have to check if there is a common monomial factor before you go any further. Okay, if you don't pull out the common monomial factor, then it's not completely factored. It's a lot like saying that 12/24 simplifies to 6/12. Well, yeah, it does, but you haven't simplified it all the way. Simplifying the fraction all the way means going all the way down to 1/2. Just be aware of that. So the best case scenario for factoring quadratic trinomials is when we have an a or a constant for our a term that's only 1. But in order to factor these, we do have to be able to identify a, b, and c. A is the coefficient of x squared. So in this example, my a is 4. B is the coefficient of x. In this example, negative 14. And c is my constant. In this example, positive 5. Looking at the next one, a, the coefficient of x squared is negative 1. There isn't an x term, which means b is 0. And c would be the constant 14. For our last example, a will equal 15, b will equal negative 24, and there's no constant, so c is 0. Now there is one pattern that you really need to memorize. It's called the difference of 2 squares, and if you memorize it, it makes your life a lot easier. A squared minus b squared. So what we're going to do is we're going to set up 2 sets of parentheses. And I'm going to take the square root of a, the first number. The square root of 9 is 3. I'm going to take the square root of b, the second number. X squared root of x squared is x. 1 has to be addition, 1 has to be subtraction, and I'm done. That's the pattern that you need to memorize. So looking at the next one, 2 sets of parentheses. Take the square root of y squared, that's y. Take the square root of 225, that's 15. 1 has to be addition, 1 has to be subtraction. Whoops. Set up 2 sets of parentheses. Take the square root of the first number. The square root of 4m squared is 2m. The square root of 25 is 5. 1 has to be addition, 1 has to be subtraction. This one's tricky because there's a greatest common monomial. I can divide both of these numbers by 9. And that gives me x squared minus 9, which fits my pattern, a perfect square minus a perfect square. So I'm going to have 9 times 2 binomials. The square root of x squared is x, and the square root of 9 is 3. 1 has to be addition, 1 has to be subtraction. The next one is also tricky. I can divide out 100 from both of these. That leaves me with 25 minus y squared. I have a perfect square minus a perfect square. So 100, 2 sets of parentheses. The square root of 25 is 5. The square root of y squared is y. 1 has to be addition. 1 has to be subtraction. All right. When a equals 1, these are the easiest ones to factor. So we're going to work through x squared plus 5x plus 6. Write 2 sets of parentheses. Continuing with my 2 sets of parentheses all the way down. Alrighty. Next, x squared can only factor to x times x. So that goes in the front of each set of parentheses. Let me keep that all the way down. Now, I need to look at the factor pairs of c. c equals 6. 6 is 1 times 6 and 2 times 3. I want, in this case, to add them to a positive 5. I know I'm adding because both of my signs here are addition in the original problem. Okay, 2 plus 3 is 5, so that's what's going to work. Plus 2 plus 3. Now the thing with these problems is you really need to FOIL back and make sure you've done it correctly. So x times x is x squared. X times 3 is 3x. X times 2, I put that in there wrong, is 2x. And 2 times 3 is 6. So this will be x squared plus 5x plus 6. I've done it right. This is my answer right here. Now there are some patterns to help you figure out where do I put the addition signs, where do I put the subtraction signs. Okay. If c is positive, then both signs have to be addition, because a positive times a positive is a positive, or both signs have to be subtraction, because a negative times a negative is a negative. So we look at b to make our decision. If b is positive, we have 2 addition signs, like in the example above. If b is negative, we have 2 subtraction signs. If c is negative, we're going to have 1 addition and 1 subtraction, because a positive times a negative is a negative. Again, we have to look at b to decide. If b is positive, then your larger factor is positive. If b is negative, then your larger factor is negative. So let's put some of this into practice. Alrighty. 2 sets of parentheses. X and x. Now I have to look at negative 4. 4 is 1 times 4 and 2 times 2. Because my 4 is negative, one of these factors is going to be negative. So I look at my b. I have a positive 3. So the bigger number has to be positive. The smaller number in each pair has to be negative. And when I add these together, I have to get 3. That's going to be negative 1, positive 4. Okay, I'm going to FOIL this back to check my answer. X times x is x squared. X times 4 is 4x. Negative 1 times x is negative x. Negative 1 times 4 is 4. So x squared plus 3x minus 4. That's what I started with. This is my answer. Next one. Start with 2 sets of parentheses. Y squared has to be y times y. Now I look at the negative 36. Goodness, I'm not sure I know all of the factor pairs of negative 36. So I'm going to come back to my calculator. I'm going to go to y equals 36 divided by x. and then I go to the table. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. One of these is going to have to be positive. One of them is going to have to be negative, because a positive times a negative will give me a negative 36. I look at my B. B is negative, so the largest factor has to be negative in every pair. Now, which pair will add up to a negative 16? And it's the 2 and the minus 18. So plus 2 minus 18. At this point, I want to FOIL it back to check it. Y times y is y squared. Y times negative 18 is negative 18y. 2 times y is 2y. And 2 times negative 18 is negative 36. So y squared minus 16y minus 36. Yep, that's what I started with. So there's my answer. Next. Start. 2 sets of parentheses. X and X. Now I have to look at 24. If I don't know my factor pairs of 24, I come back to the scrapping calculator. I go to y equals, oops, pen down first. Get rid of that mark. Y equals 24 divided by X. Go to your table. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Alrighty. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Now, my 24 is positive. That means both of these numbers are positive, or both of these numbers are negative. When I look at B, I need them both to be negative. So which ones add up to 10? Negative 4 and negative 6. And when I FOIL this back, you can see that you're correct. Next example. 2 sets of parentheses. X squared has to be x times x. Now I look at 16. 1 times 16, 2 times 8, 4 times 4. The 16 is positive, so my factors are either both positive or both negative. I look at B, and they're both going to have to be positive. So 4 plus 4 equals 8, and that's my answer. FOIL it back to check. Next up, 2 sets of parentheses, x times x. Now we look at 22. 22 is 1 times 22 and 2 times 11. Because the 22 is positive, both factors are positive or both factors are negative. I look at my B, and they're both going to be positive. So positive 2 plus 11 will add up to 13. Last example here. 2 sets of parentheses, and they both start off with x. I look at 24. 24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6. Because 24 is positive, either both of these are positive or both of these are negative. I look at B. They're both going to have to be negative. Which ones add up to negative 10? Negative 4, negative 6. Alrighty, if you cannot factor the quadratic, it is prime. This one doesn't work because this is addition. If it was subtraction, we could factor it. But we cannot factor a perfect square plus a perfect square. With the next one, if I look at factors of 4, that's 1 times 4 and 2 times 2. The 6 is positive, so that means the largest factor has to be positive. None of these add up to 6. This one adds up to 3. This one adds up to 0. There's no way to make that work. With the next example, I look at 44. 44 is 1 times 44, 2 times 22, and 4 times 11. Because it's negative, one factor has to be positive, one factor has to be negative. When I look at the middle, the biggest one is positive. If I add these up, I get 43, 20, and 7. None of those equal 3, so they doesn't factor. It is considered prime. Okay, at this point you need 4 questions and a summary.